We've got rocket firings left, right, and center coming from China and the US, including an interesting observation during the test of future SLS hardware. India, Poland, and Hungary return to human spaceflight missions after 3 decades or more. France is set to launch a Baguette, and we've got new and impressive images of Earth from space, and also of space from Earth. All that and more coming up this week in Spaceflight. Let's start off this week's episode with some rocket firings. Even though NASA's Space Launch System, or SLS, only has 1 flight under its belt so far, Northrop Grumman is developing a new booster for Block 2 of SLS, which is slated to fly starting with Artemis IX. The Booster Obsolescence and Life Extension, or BOLE program, is needed for SLS to fly past Artemis VIII, if the program survives potential budget cuts, of course. Northrop Grumman only had 8 sets of shuttle-era steel cases, and 1 set was already expended when Artemis I flew back in November of 2022. Enter BOLE and its carbon fiber composite cases, the first full-scale motor test for which was readied at NGC's test site in Promontory, Utah, 130 kilometers northwest of Salt Lake City. The test motor fired on June 26th at 1825 UTC after about an hour-and-a-half delay from its original start time. The test was scheduled to last for 2 minutes and 7 seconds and was monitored over 763 data channels. In that time, the motor was set to generate 3.9 million pounds of thrust, burning over 1.4 million pounds of propellant. The test objectives included demonstrating the full-scale ballistic performance of the design, along with insulation and nozzle ablative performance, thrust vectoring performance, and more. As well as the test was going, about 10 to 15 seconds from the end of the test, the nozzle suffered a rather explosive anomaly, visually liberating chunks on the nearby hill. Now, it's worth mentioning that this is a different design from the solid rocket boosters that flew on Artemis I and that are set to fly on the next SLS mission, Artemis II. As mentioned before, this new booster design won't fly, if it flies at all, until at least Artemis IX. BOLE makes use of new carbon composite casings instead of the steel ones used on shuttle and current SLS rockets. The BOLE nozzle has been redesigned with a different throat and a 2-foot extension. This booster is also slightly larger. It's 2 feet longer and 2.1 inches wider. That's 61 centimeters and 5.3 centimeters respectively. But the differences go beyond that. The BOLE boosters will use electric thrust vector control, or ETVC, instead of the legacy boosters' hydraulic controls, saving a lot of mass. The hydraulic controls used hydrazine to power the hydraulic systems, so the BOLE boosters will also get rid of that nasty product as well. On top of that, the booster uses a whole new propellant mix and binder, now using HTPB instead of PBAN. The list of improvements and updates goes on, all in order to improve their performance and reliability. The BOLE motor cases for this test are unpainted but have a bluish cast due to being wound with copper wire to create a Faraday cage to protect the case and its contents from lightning. This is similar to what Boeing did with the 787's composite fuselage, as composites don't conduct electricity. The flight boosters, though, will be painted white. BOLE motors are manufactured using the same facilities that Northrop Grumman uses to build current SLS boosters. NSF's own Jack Beyer, Philip Sloss, and Justin Davenport toured the facilities on Wednesday and saw Artemis 4 and 5 segments being manufactured and processed, along with the equipment used to fabricate the BOLE boosters. Of course, now the question is whether development and testing of these will continue given the current state of affairs with NASA's budget. It's already hard to see SLS surviving past Artemis III, let alone past Artemis VIII. If everything continues as planned, then the design and development phase would look very similar to the design and development phase of the current 5-segment SRBs used on SLS, meaning we could see another demonstration motor firing in the near future, followed later in the process by 2 qualification motor firings. Now, during this story, you might have noticed a lot of footage captured by our own Jack Beyer in the field.
Thanks, Alicia. Jack Beyer here, reporting from Promontory, Utah, where Northrop Grumman just tested their BOLE DM1 booster for the very first time.
We've released a full replay of the burn from close-up and from further angles on our channel, so you should definitely check out that video. This kind of coverage is made possible by people just like you watching out there who, tickle the algorithm in our favor, which then tells others that they should watch these videos too. So if you like this kind of coverage, any kind of support, watching and liking our videos, or subscribing to our channel goes a long way to make it happen. So thank you. Now on more Artemis test firings. This past week, NASA fired up a new RS-25E engine in preparation for future Artemis missions. The engine, with serial number 20001, was fired up on June 20th at the Fred Haise test stand at NASA's Stennis Space Center in Mississippi. While the test was surely spectacular and visually amazing, just like previous tests, unfortunately, no video was released of it. In fact, until just about a year ago, the Stennis Space Center used to live stream these tests on their own YouTube channel, but then just simply stopped. Since then, we rarely get any kind of footage like this of engine testing, or, like in the case of this one, we just have one single photo. The RS-25E was developed as an upgraded version of the Space Shuttle main engine to be used on SLS once the current stock of shuttle engines runs out. Since there were only enough parts for 16 engines, that means that there were only enough engines for the first 4 SLS launches, so up to Artemis 4. Starting with Artemis 5, these RS-25E engines will be the ones powering the SLS core stage. They're meant to be cheaper while also having a higher thrust, like the BOLE boosters that we just talked about, but it's not really clear whether these engines will see flight or not. As usual, it's going to have to be a wait-and-see situation. From the US, we now go to China, which has also had quite a lot of rocket testing in the past few weeks. On June 20th, Landspace fired up the first stage of its upcoming Zhuche 3 rocket. This rocket is set to be a partially reusable rocket fueled by liquid methane and will draw upon the company's experience flying the Zhuche 2 and the Zhuche 2E rockets. The first stage, fitted with 9 Tianqi 12A engines, fired up for about 45 seconds, producing about 770 tons of thrust. The test, which was performed at the same site that it'll eventually be launched from, demonstrated that the rocket's design is robust enough to potentially at least make it far enough into the air that it won't damage the launch site. Now, this first stage in particular was built just for ground testing, and although it may still fly in the future, it won't be on Zhuche 3's first launch. The first stage for the first launch is currently undergoing manufacturing and integration while Landspace finalizes preparations for the maiden launch. That first launch was originally planned for September, but Landspace has now moved that date to the last quarter of the year, so don't be surprised if it ends up launching next year. Landspace plans to start booster landing tests with the first launch of this rocket, so whenever it happens, it's bound to be a rather interesting launch to watch. Another rocket close to its debut from China is the Kinetica 2 rocket developed by HyPrSpace, a subsidiary of the Chinese Academy of Sciences. While the Kinetica 1 rocket is an all-solid fueled 4-stage rocket, Kinetica 2 is a larger 2-stage rocket that uses kerosene as its fuel and is also planned to be partially reusable. In the last couple of weeks, HyPrSpace performed a successful hot fire test of both the first and second stages of the rocket, paving the way for a first launch later this year. The first stage test was performed on June 11th at the company's Liquid Propulsion Test Center located in the mountains north of the large city of Guangzhou. The test ran for the full ascent burn duration, running the 3 YF-102 engines of the first stage for nearly 3 minutes. The second stage test was performed more recently, just this past week, at the same test site. That one also ran for the full burn duration, firing the single vacuum-optimized YF-102 engine for nearly 5 minutes. If all goes well with launch preparations, we should see the first Kinetica 2 launch later this year, followed in 2026 by the first booster landing tests. Last week, we reported on a bunch of European space news coming from the Paris Air Show. And this week, we've got even more, starting with some good news for Spaceplane fans. The French company Dassault Aviation is working on one, and the European Space Agency seems to be interested. What's more, it's also got support from the French Ministry of Armed Forces. Dassault's Spaceplane is called Vortex, which is short for what translates in English to Reusable Orbital Transport and Exploration Vehicle. It's a very versatile vehicle designed for both civilian and military applications. The company wants it to deliver payloads to space and transport crew and cargo to and from space stations, but it'll also be able to rendezvous with other satellites for in-orbit servicing or even bring them back home. Dassault is no stranger to spaceplanes, as it's participated in many spaceplane programs, including ESA's Intermediate Experimental Vehicle, which has now evolved into Space Rider, as well as ESA's cancelled Hermes spaceplane and NASA's X-38. But before building full-scale vehicles, the company plans to test small-scale spacecraft, and the French military has now agreed to support the development of the first demonstration spaceplane. Meanwhile, ESA has also signed a letter of intent to cooperate on the program. It's not a solid commitment just yet, but it's a promising first step nonetheless. France is launching a Baguette into space? Wait, no, scratch that. The French company HyPrSpace plans to launch a prototype rocket called Baguette 1 from a missile testing site in mainland France. The company announced that it signed an agreement with the French Defense Procurement Agency to test its suborbital Baguette 1 demonstrator from the DGA missile testing site in southern France. This vehicle is 10 meters tall and is a single-stage rocket designed to carry 300 kilograms into space. HyPrSpace hopes Baguette 1 will demonstrate the company's hybrid rocket engine in flight, which it then plans to use for a more powerful rocket called Orbital Baguette 1. This rocket is expected to be approximately 6 meters tall and capable of carrying payloads of 250 kilograms into a 400-kilometer low Earth orbit. The engine, called Terminator, has already been successfully test-fired 3 times since 2024. Having a launch pad will enable HyPrSpace to assemble the Baguette 1 rocket and conduct all necessary tests to get ready for orbital launches. The first test of the suborbital Baguette is expected to occur in 2026. Rocket Lab signed its first dedicated launch contract with the European Space Agency to launch the first 2 satellites for ESA's LEO PNT constellation. That's short for Low Earth Orbit, Positioning, Navigation, and Timing. ESA is working on this constellation to study how navigation satellites in low Earth orbit can cooperate with Europe's Galileo and EGNOS systems. Most navigation satellites are in medium Earth orbit, but it's believed that a lower constellation will help to cover more locations, including the polar regions, indoors, and under heavy foliage. Rocket Lab will launch the first 2 of the 10 satellites for this constellation during a 3-month window starting in December. According to ESA, the contract was, quote, necessary to meet the scheduling requirements. In other words, the launch cadence for Ariane 6 and Vega C is so low that ESA can't even launch its own satellites when it needs to. Hopefully, the European launch providers get their act together soon, but for now, it's nice that ESA can get some help from the other side of the world. And speaking of launching from the other side of the world, US launch providers will soon be able to launch from Sweden, as the country signed a technology safeguards agreement this week. This essentially ensures that sensitive technology will be handled appropriately, and it won't end up in the wrong hands. Specifically, they signed the agreement to allow for commercial launches from Swedish spaceports. So who's going to launch? Well, last year, Firefly Aerospace announced plans to launch its Alpha rocket from S-Range in northern Sweden. S-Range has seen hundreds of suborbital launches since the 1960s, but now it wants to get in on some orbital action as well, and Firefly is one of the companies that might make it happen. The company's been working with the Swedish Space Corporation to develop infrastructure at S-Range, and the new agreement helps to cross off another important milestone towards its first flight. Last year, Firefly said that it wanted to launch as early as 2026, but it's not clear whether that schedule still holds. The European Space Agency announced that 2 new astronauts will travel to the International Space Station. Sophie Adenot and Raphaël Liégois are set to visit the ISS for the first time in 2026. Both are graduates of ESA's 2022 astronaut class and the first career astronauts from this group to be assigned to a mission. Liégois is a Belgian neuroscientist, and Adenot is a French helicopter test pilot. This will be her first mission, and she's calling it Epsilon. She unveiled the mission name and patch at the Paris Air Show alongside ESA Director General Joseph Aschbacher and French President Emmanuel Macron. Little is known about the details of these 2 astronauts' upcoming missions. However, Adenot is likely to fly on the SpaceX Crew 12 mission. Once on station, she's expected to lead European scientific experiments, medical research, and Earth observation support, as well as assist with station operations and maintenance. The usual for ESA astronauts on the station, really. It's always exciting when new astronauts get the chance to build a future in space, and we wish them a great time on the ISS. ESA revealed the first images from its Biomass satellite during the Living Planet Symposium on June 23rd. The satellite was launched just 2 months ago from French Guiana atop the Vega C rocket. It's on a mission to study carbon storage, forest health, and ecosystem shifts as part of ESA's Living Planet program, which aims to help the entire world learn more about taking better care of Earth's health. To do all this, Biomass will observe forests between 75 degrees north and 56 degrees south with its P-band synthetic aperture radar instrument. The initial images released by ESA are captivating, but they currently have limited practical use. This is because Biomass is still in its 6-month commissioning phase. after which the spacecraft should be able to track and record how carbon levels change in each forest, as well as the amount of carbon that's stored there. With these initial images and a satellite that's functioning smoothly, ESA's confident that Biomass will achieve its goal. The images are stunning, with each color highlighting different parts of the world. For example, green tones primarily represent rainforests, while red shades indicate floodplains and wetlands. Blue and purple shades typically denote grasslands, and black areas usually represent rivers and lakes. Additionally, the radar can penetrate forest canopies, allowing for better terrain imaging of each forest and more accurate measurements of the carbon stored on the forest surface. Not only that, but a few pleasant surprises have also come from the first images. Using the same P-band synthetic aperture radar, ESA can now peer 5 meters into dry sand and map subsurface features in deserts. With this, Biomass can discover new water sources in dry areas. Moreover, it can also help to observe ice sheet movement and forest topography. This means the Biomass can be used for much, much more than its original purpose. There's still so much to learn about the world that we live in and how humanity's actions impact it. So keep an eye on this mission because it might make some really interesting discoveries. Now we'll take a look at some other stories across space, starting from Chile and the Vera Rubin Observatory. This week, the National Science Foundation, the other NSF, released the first images from this brand new observatory located in the mountains of northern Chile. While located on Earth, and therefore suffering from the problems of atmospheric distortion, this observatory has a larger mirror and field of view than space telescopes like Hubble and James Webb. In fact, its field of view is so large that it could fit 7 full moons across. Because of this, it's able to observe the entire visible sky in just a few days, and it will be continuously revisiting every part of the sky over a 10-year period. This will build up lots and lots of data as part of a giant survey called the Legacy Survey of Space and Time. And that's because, due to the speed of light, observations of the universe across space also mean observations of the universe across time. And there's gonna be a lot of these. In only its first 10 hours of observations, Vera Rubin has observed 10 million galaxies and thousands of asteroids, 2,104 of which are new. Over its lifetime, it's expected that Vera Rubin will discover millions of new asteroids and observe up to 20 billion galaxies. And yet, that's still only about 1% of all of the galaxies thought to exist in the observable universe. If anything is for sure, it's that there is a lot to discover up there. After another tense lunar landing earlier this month on June 6th, iSpace has released its analysis of what went wrong during Hakuto R's second mission, and it's more or less what they already suspected that day. According to the information released by the company, during the final landing phase, the laser rangefinder experienced an anomaly that prevented it from obtaining valid or updated information about the vehicle's distance from the lunar surface before the crash landing. iSpace has now been able to confirm that this anomaly was not caused by the landing guidance control software, propulsion issues, or something else like a power supply problem. They discovered that it was actually all related to a lower than expected performance of the laser rangefinder system itself. iSpace is now forming a task force to investigate why this problem occurred and will collaborate with the Japan Aerospace Exploration Agency to improve the technical capabilities of the next lunar lander. iSpace's founder and CEO, Takashi Hakamada, mentioned that iSpace will not let this be a setback. We will not stop here, but as determined pioneers of the cislunar economy, we will strive to regain the trust of all stakeholders and embark on the next mission. Never quit the lunar quest. On April 1st, an unexpected pressure drop was observed in the primary Xenon propellant line of NASA's Psyche spacecraft, which is en route to an asteroid believed to be the ancient metallic core of a planet. This caused NASA to shut down all operations of the 4 electric thrusters on the spacecraft as a safety measure, and over the following weeks, the engineering team eventually narrowed down the problem to a valve malfunction in the primary line. Fortunately, an identical backup propellant line restored the propulsion system to full power, which means Psyche can still use its thrusters and therefore get back on track. But since a small amount of time and delta V were lost fixing this issue, the thrusters will now need to run for an equivalent of 3 months from now until November to get it back on its path towards Mars. Psyche will use the gravity assist of Mars to slingshot itself into the asteroid belt, where it hopes to arrive at its target in August of 2029. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. This week we had launches all around the world, starting off with a launch from China. The Changzheng 3B carried Chinasat 9C, also known as Zhongxing 9C, which is a communication satellite that'll operate from geostationary orbit. It'll replace the Chinasat 9 satellite, which was launched in 2008. Of course, we also had a couple Starlink missions this week, both from Florida. Together, they added another 54 Starlink V2 mini satellites to the constellation. Continuing with internet satellites, ULA's Atlas V lifted the second batch of satellites for Amazon's Kuiper constellation into orbit. This mission was supposed to launch a week earlier, but it was delayed to check out a potential issue with a nitrogen purge line. This week, Atlas V finally lifted off in its most powerful configuration, nicknamed the Bruiser, featuring 5 solid rocket motors. A Falcon 9 also lifted off from California to launch SpaceX's Transporter 14 mission. It carried 70 payloads to space, including 2 re-entry capsules that we covered in last week's episode. The first was Varda's Winnebago 4 spacecraft, which is the company's 4th mission, but the first to use Varda's in-house developed satellite bus. The capsule has yet to re-enter at this time, and we don't yet know when it will. The second capsule was for the exploration company's Mission Possible. Unfortunately, that one was not completely successful. The capsule re-entered and even made it through the blackout period, but lost communication a few minutes before splashdown. The company still considers it a partial success though, and it plans to use what it learned from this mission for its next capsule. Later in the week, the long-awaited Axiom 4 mission finally lifted off from Kennedy Space Center. As you might remember from previous episodes, this mission had been delayed many times, most recently by leaks on the ISS and its booster. The passengers riding to space on Falcon 9 were former NASA astronaut Peggy Whitson, who's now director of human spaceflight at Axiom Space and serves as the commander on the mission. The pilot on the mission is Shubhanshu Shukla, who's an astronaut for the Indian Space Research Organization. The mission specialists are ESA project astronaut Sławomir Uznański-Wiśniewski from Poland and Hungarian astronaut Tibor Kapu. This is Whitson's 5th spaceflight, and the 3 others are all first-time flyers representing each of their respective nations' return to space in more than 40 years. They were joined by their zero-G indicator, a plush baby swan named Joy. The 4 arrived at the station the next day, docking at the space-facing, or zenith port of the Harmony module. They're expected to stay at the station for 14 days, where they will work on nearly 60 experiments and studies. This mission was the first for Crew Dragon C213, which is the final Dragon that SpaceX will ever produce, and the 5th crew capsule in the company's fleet. As is tradition, the first crew to fly on the capsule gets to name the spacecraft, so the Axiom 4 crew chose the name Grace. Over on China's Tiangong space station, 2 astronauts performed a 6.5-hour spacewalk. Chen Dong and Chen Zhangwei stepped outside the station to install debris shields and perform maintenance and inspections. Over in deep space, NASA's Parker Solar Probe screamed past the Sun on its 24th so-called perihelion, or closest approach to the Sun. As it did so, it traveled closer than any spacecraft ever has, and had to endure temperatures of up to a blistering 930 degrees Celsius. On June 22nd, 3 days after that closest approach, the spacecraft phoned home, reporting that all systems were healthy. This was the final perihelion of the spacecraft's primary mission. What's next for the Parker Solar Probe will be decided next year. But of course, it won't wait for that, and it'll continue to orbit around the Sun with a close approach like this one every 88 days. And at the end of the week, an Electron snuck into the schedule, but it wasn't the mission that we all expected. Rocket Lab stood down from its Symphony in the Stars mission earlier in the week, first for weather and later for further checkouts, but quickly moved on to another customer. This mission launched 4 satellites for Hawkeye 360, so Rocket Lab named it Get the Hawk Outta Here. Going into next week, one of the first missions that we might see is the one that Rocket Lab didn't launch last week. The company's now scheduled the Symphony in the Stars for June 28th, which would mark a turnaround record for the launch site at less than 48 hours. As always, Falcon 9's expected to fly a few Starlink missions. SpaceX is also set to launch the Meteosat 3rd generation sounder satellite for EUMETSAT, which will monitor Europe's weather and also carry the Sentinel-4 instrument. Last week, Blue Origin was supposed to launch another crewed mission on its New Shepard rocket, but that one was scrubbed after the weather didn't cooperate. We might see NS-33 launch this week instead. Over in Japan, the final H-2A rocket is set to launch from Tanegashima, carrying a satellite that will monitor greenhouse gases. In Australia, Gilmour Space is gearing up for the maiden flight of its Eris rocket again. You might remember that it deployed its fairing on the pad in early May, but it's now outfitted with a new one, which is currently being tested. Gilmour has a narrow launch window opening on July 1st, so we hope the weather cooperates. Finally, the next Progress cargo resupply mission is set to launch to the ISS this week, lifting off from Kazakhstan on July 3rd. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.